All right, so we're going to do our first balancing of a nuclear reaction. Now, nuclear reactions balance differently than regular chemical reactions. All we had to worry about for regular chemical reactions was if there's the same number of each atom of each kind of element on the left and the right hand side of the arrow. It doesn't work that way in nuclear processes because most of them involve changing an element from one thing into a different element. So you can't balance element for element across the arrow. So what we do with these is we balance charge and mass. So mass balancing now means nuclear masses. And charge balancing is how many protons. So you have the same number of each on both sides of the arrow. Now the first one we'll go through is gamma emission. Now in all of these processes where you see emission, either emission or decay, that means that that particle is produced, it's a product. And if you don't get the little particle on the right side of the arrow, you can't get the right answer on most of these. Okay. So gamma emission means 0 over 0 gamma is a product. Now these equations for gamma are not terribly interesting because they don't involve any change in mass or charge. It's still the same element on both sides. So in some ways it's not a nuclear reaction, it's just a relaxation reaction from a high energy product of a nuclear process to a ground state. Okay, so let's say we take our example from our page, it was nickel 56. So 56 over 28 Ni. Got to remember how to write those nuclear symbols. 56 is the mass number. This is always a whole number. It's not the number off the periodic table. It's the number of protons plus neutrons. That has to be a whole number. And the bottom number is the number of protons, the atomic number. So the 28 here has to match Ni because nickel is number 28 on the periodic table. So it's undergoing gamma emission. That means it produces a gamma particle, or sorry, a gamma ray. And then we have to figure out the leftovers. And that's usually the task of these nuclear reactions, is either to figure out what the leftovers are, or what this particle was if you know both of these, or what the original one was if you know both of those. But most of them involve you figuring out what the product atom is. Now in these processes, we call this element over here the parent atom. The particle that's emitted, this is the daughter atom, the one that's produced by the parent. Now when we balance these equations, this one's going to be easy because we have zeros here, but let's go through the process. What you want to do is make sure that the total of the mass units on the left side of the arrow matches the total of the mass units on the right side of the arrow. So we add up all the masses on the left. In this case it's 56, because there's only one particle over here. Subtract off how many are accounted for in the particle. 56 minus 0 means we have a mass of 56. We do the same thing for the charge. There's 28 charges over here, none of which are accounted for by the gamma. So it must be a 28 there, which means this must still be nickel. So in the case of gamma emission, parent and daughter atoms are the same. There's no change in identity of the atom, which is why they're not very exciting reactions to write or very complex to balance, because they're already balanced by themselves essentially. Okay, next video we'll start in on the alpha particles. Be right back.